To add or subtract rational expressions having different monomial denominators, the first thing we need to do is to find the least common denominator. So for our least common denominator, since we have only an x factor in this rational expression and a y in this one, the least common denominator should contain each factor the greatest number of times that it occurs in any of the individual factorizations. We're done. Next, we move on to multiplying each rational expression by a form of 1 made up of the factors of that least common denominator missing from that expression's denominator. In other words, I'm going to take this first rational expression. It has a denominator of x. I need it to have an xy. So I'm going to multiply the denominator by y, but to maintain equality, I'll also multiply the numerator by y. Y over y is 1. The result, which will give me that least common denominator, that's the goal. Doing the same with the next fraction, or rational expression, it has a denominator of y. I want it to have an xy, so I'll multiply the denominator by x, but to maintain equality, I'll also multiply the numerator by x. X over x being 1, multiplying by 1 doesn't change. Simplifying this then, we have a 4 times y for a 4y in the numerator and an xy in the denominator of the first rational expression. Doing the same with the next multiplication of rational numbers and commutative property, I'll list the x term first. I now have common denominators, which we can then move into adding the numerators and expressing that sum over the common denominator. The last thing is to simplify if possible. In the numerator, there's nothing common between these two terms other than 1, so there is nothing left for simplifying. This rational expression is in simplified form. Here we have another rational expression where we have subtraction involved. First order of business, find that least common denominator. For 3a, we can see it is just 3a. For 4a squared, its prime factorization is 2 times the a squared. Our least common denominator then will be each factor the greatest number of times that it occurs. We need to have 2 to the second power. We need a 3, and each shares an a, but it has to be to the greatest power that occurs in any of the individual factorizations, which means an a squared. Simplifying, we end up with a 12a to the second power for our least common denominator. Repeating the steps that we did in the first example, we move on to multiplying each rational expression by a 1, a very special one that brings it up to that common denominator that we're looking for. Since we have a 3a and the goal is 12a squared, we'll need a 4 and an a so that the denominators multiply to give us that least common denominator value. To maintain equality, we'll multiply the numerator by the same quantity, so we're multiplying the rational number by 1. Moving on and doing the same with the next fraction. The denominator has 4a squared. The variable is covered, but we need a 12. To achieve that, we'll multiply the denominator by 3 and the numerator by 3. 3 over 3 is a 1. Simplifying, by multiplying these rational expressions together, in the numerator we have 20a over 12a squared. In the second, we have 3 times 3, or 9 over 12a squared. We have the common denominator. We're now ready to simplify the subtraction, because of having that common denominator requirement, subtracting the numerators, 20a minus 9 over the common denominator of 12a squared. Last step then is to simplify if possible. 20a and 9 have nothing other than 1 in common, so we can't factor that. And this binomial is not in the denominator, so this answer is in simplified form.